All right, last thing we're going to look at in this section of notes is going back to calculate probabilities resulting from the sum of our independent variables. So we saw this with our linear combinations earlier, and now we want to look at having two separate probabilities and what happens when we look for the function for the sum of those distributions. So let's go back to that original formula we saw in the syllabus. And this is also the formula that's in your formula booklet for this. So I want to focus on this side over here. Remember, t was our dummy variable and x was the values x we could take on. So let's look at our g of x of t. So I could say that this one is g sub x of t is e to the tx as it's written. And I could think of it this way, as the sum of my x values, t to the x. And now, let me make those x's match. I could do the same thing for y. T to the y, and say that that's the sum of my different y values, probability that y equals y, t to the y. And this is across all the values that y can take on. So now if I look for g of z, so that's going to be g of x plus y, well then I'm going to have e t to the x plus y. So that's going to give me a double sum, because I have to sum across the x values and I have to sum across the y values. And then I'm going to have the probability that x equals x along with y equals y. And then I'll have t to the x plus y. Well, I can separate this out because we're talking about independent variables. So I can only do this separation because they're independent, but I could say that this is the sum of x, t to the x, and I can separate my probabilities because they're independent. So then I have another sum, y, probability that y equals y, t to the y. Well, this is the same as my e of t to the x times e t to the y, which of course is the generating function for x times the generating function for y. So if I have two independent probabilities, then if I want to find the sum of their probabilities, I multiply their generating functions.